Hello dear students, welcome you all for transmission and distribution class. So today we will see the nominal pi method in the medium transmission line. In the previous class you have seen the nominal T method. So today we will go with the nominal pi method. What is this nominal pi method? So in this method, total capacitance of the each conductor is divided into two halves, and one half is being at the lumped at the sending end, another half is lumped at the receiving end. In the previous method, in T method, what you have done? Total capacitance is lumped at the middle of that, then total resistance and reactance of the inductance is taken exact half of in one either side of the capacitance. Now here, instead of that one, total resistance and inductive reactance is same as per line, but the total capacitance is made equal half, and at starting end one half is kept, and at the receiving end one half is kept. So this is what the figure of the nominal phi method. You can see Vs, Is, then C by 2 is there where current IC2 flows, then next is RXL where current IL flows, then once again the capacitance C by 2 is there where IC1 flows, then at last IR will flows to the load, and the voltage across the load is considered as the VR. The things are same. IR is load current or receiving end current, IS is sending end current, IC is the charging current, VR is the receiving end voltage, VS is sending end voltage, IL is the line current, R is resistance, XL is the reactance of the inductance. Okay. So common method, we know that VR is taken as reference and we are writing VR plus J0 in the vector type. So then assuming that inductive load, usually the loads are of RL type only, that's what we are considering lagging load, that is IR vector is nothing but IR cos phi r minus J sin phi r, where cos phi r is the receiving end power factor. Okay. Now charging current at the load end IC1, because two side we are having charging current. First end is IC1 is the current on the capacitance which is near to the receiving end. We can write that IC1 is equal to J omega C by 2 VR, because C is C by 2 there. Okay. So line current IL is nothing but what? IR plus IC1. IR is the load current which flows in the load. IC1 is the current flowing in the capacitance. Togetherly those two current will nothing but IL. You can see in the figure, it is very clear that IL is equal to IR plus IC1. Or sending end voltage, we can write it as Vs is equal to VR plus IL ZL. You can directly write that one. Okay. Or that VR is equal to IL plus R plus JXL. You can write that one. Then charging current at the sending end, you can write IC2 is equal to J omega C2 into Vs. Or sending end current IS can be written as IL plus IC2. You can see in the figure, it is very clear. So nominal phi methods phasor diagram is as shown. How to draw the phasor diagram, that we will see one by one. First we have to take the reference as VR, writing the VR. Then IR lags the VR with an angle phi r, writing a lagging current of IR. See second figure. Then the charging current IC1 leads the VR by 90 degrees. So putting that at the IR points that IC1 and 90 degree to VR. You can see the IC1 how it draws. We know that IR plus IC1 is nothing but IL. Then adding those two, we will get the IL there. Once we know the IL, we need to find the IL is a cost for the drop of ILR and ILXL. ILR is in phase with the IL, so we can write ILR with VR as it is shown in the figure. Then coming to XL, ILXL is having 90 degree to the current IL, so it is drawn as it is. So once we are knowing ILR, ILXL, we will add that one, that is ILZ. So ILZ is nothing but the drop. VR plus ILZ is nothing but the Vs, that is the sending end voltage. So by joining those two lines we will get the Vs. So once we know the Vs, we know that charging current IC2 leads the voltage VR by 90 degree. Same IC2 is drawn there. Once we have drawn the IC2, IL plus IC2 is nothing but the IS. Join the point, there we will get the IS. That IS is having angle phi s with the voltage Vs. So this is what the drawing the phasor diagram of the nominal phi method. We will see one problem here. A 3-phase 50 Hz 150 km line has a resistance, inductance, inductive reactance and susceptance of 0.1, 0.5 ohms and 3 into 10 raised to minus 6 Siemens per kilometer per phase. If the line delivers 50 megawatt at 110 kV and 0.8 power factor lagging, calculate the Vs and Is using the nominal phi method. Okay, now we have to write down the things. What are the things given? Length is given 150 km, resistance per phase per kilometer is given 0.1 ohm, That is for the 150 kilometer. If you multiply with 150, you will get 15 ohms. Reactance per phase per kilometer is 0.5 ohms. For 150 kilometer, it is multiplying by 150, you will get 75 ohms. Susceptance is per phase per kilometer value is 3 into 10 raised to minus 6. For 150 kilometer, after multiplying that one, you will get 4.5 into 10 raised to minus 5 Siemens. So receiving end voltage VR is 3 phase value is given. So to get the single phase, that is 110 by root 3, will get 63,508 volts, and receiving end power is given is 50 megawatt, that is 15 to 6. Receiving end power factor is given, that is cos phi r is equal to 0.8 lagging. So we need to find out what is Vs and what is Is using the nominal phi method. Writing the VR as it is, first VR plus J0, finding the IR we are knowing that PR by 3 VR cos phi r because 3 phase power. So we will get 328 amps. Once we are getting the magnitude of IR, we need to find the vector value of IR, that is cos phi r is known. So putting this one, we will get 328 into at an angle minus 36.86 amps. So charging current IC1 we need to find out, that is the J omega y by 2 into we are knowing that one because already omega is there, means y is omega c only. So that is y by 2 directly given. So we will put the values, and we will get the values as J 14.28 as the IC1. So finding the IL, adding IR and IC, we will get 319.63 at an angle minus 34.82 amps as the line current. So finding the Vs, once we find the IL, means we need to go for the finding the Vs, that is VR plus ILZ. So Z is known, 15 plus J 75. So writing all these values, we will get the Vs. Once we get the Vs, that is in phase value, that is 82,976 at an angle 11.836 volts. So finding it line voltage, we need to multiply it by root 3, we will get the values of the line voltage. So next thing is we need to find the IC2, that is the J y by 2 into Vs. So y by 2 value we are knowing, just put the Vs value, we will get the current as IC2. So once we get the IC2, we need to find the IS, that is IC2 plus IL. So we will get the current as IS. So this is what the method for finding the your sending end current, sending end voltage using the nominal phi method. So this is very simple method compared to the nominal phi method to T method is very simple, that in phi method capacitance are made half, in T method resistance and inductive reactance are made half. Here capacitance are used 2 halves, one half is used at the sending end, another half is used at the receiving end. In case of T method, at the midpoint total capacitance is lumped. So this is regarding your nominal phi method. We will see some problems in next class, and we will go to the next is long transmission line. Then we will see the ABCD parameters. We are knowing a sending end and receiving end current and voltage is given with relationship using the ABCD parameters. That is the sending end voltage and sending end currents are expressed in terms of the receiving end voltage and receiving end current, that we will see in the coming classes. So for the time being, you just note down this figure and try to write the phasor diagram by your own and solve the problem whatever I have solved in this notes. Once again you go through all these things, you will come to know how exactly to draw, and the drawing phasor diagram is very simple. One by one, step by step I have explained here. You try to understand the concept. Okay, if you find any difficulties, you can ask me. Thank you.